So as I said, again, thank you for attending to this session on data governance for smart manufacturing. I think you can see my screen. If no, please someone from the other presenters, please let me know. First of all, before starting with the presentations, I would like just to provide a definition of data governance. This is a definition provided by the Data Governance Institute. And according to them, data governance is a system of decision rights and accountabilities for information-related processes executed according to agreed upon models which describe who can take what actions with what information and when, under what circumstances, using what methods. So at the end, let's say it's a system to manage and organize data use in an organization. And as you can see in this graphic in this figure in the right that is provided by the Data Management Association, it covers several areas, such as data quality, metadata management, data security, that includes also privacy, of course, data modeling and design, etc. In these presentations, we are not going to see all aspects from all these areas because we have limited time, but we will try to provide some or talk about our experience in our projects on some of these areas. Regarding smart manufacturing, smart manufacturing is defined as the notion of orchestrating physical and digital processes within factories and across other supply chain functions to optimize current and future supply and demand requirements. This is accomplished by transforming and improving ways in which people, process, and technology operate to deliver the critical information needed to impact decision quality, efficiency, cost, and agility. In this session, we count with the participation of different data-oriented projects in the smart manufacturing area, such as Cdmp, IntelliQ, Data4.0, and I4q. And this is the program for the presentations today. We have this welcome and introduction. Now we will start with a presentation about legal issues and regulations regarding data in smart manufacturing environments provided by Cdmp. After that, we have a presentation about a systematic review of data quality for CPS, IoT, or Industry 4.0 applications that will be made by IntelliQ and Data4.0. Then we have a presentation about data management and governance that will be made by IntelliQ. And finally, we have a presentation about I4q solutions that support data governance implementations that will be made by I4q. So let's start with the first presentation. As I said, after each presentation, we have a 5-minute round in which you can provide your comments or your questions in the chat. The presenter will try to respond to these questions. So let's start with the first presentation. This one is data governance, legal issues, and regulations. And what we're going to see in this presentation is the following points. First of all, I make a small introduction about the Cdmp project, as a brief overview of the project. So we will see data lifecycle in smart manufacturing environments. This will be just a very simplified explanation on this lifecycle. We will see possible personal data related issues in this kind of smart manufacturing ecosystems, environments. We are going to see also possible legal problems or legal issues that may arise in data sharing in the smart manufacturing ecosystems. Finally, we're going to see the new regulations from the European Commission that regulate different data uses, no? Such as the Data Act and the data governance. So first of all, I will provide a brief introduction on Cdmp project. Okay, so the Cdmp project, the Zero Defects Manufacturing Platform, is a European project funded by European Commission, in which participate 30 partners from different backgrounds. So we have software developers, users that are manufacturers, universities, research centers, and also consultancy companies, no? And the main objective of this project is create a digital platform that support manufacturers to reach zero defect goals. So at the end, Cdmp enables, as a platform, enables to manufacturers, smart manufacturers, to interconnect their systems. That can be, for example, their equipment in the shop floor, or their different management systems, such as the ERP, to applications, different applications, or different software components that enable to improve product or process quality, you know? So this is an open source platform mainly, and is addressed also to SMEs. It's one of the main objectives to be addressed to SMEs, no? At the end, this platform will provide also, it's considered an Industry 4.0 platform, and will provide also a marketplace where software developers can develop different applications and components that will process the data collected from these different sources, no? From the smart manufacturer systems, to improve product quality, process quality, and energy efficiency. These solutions will be artificial intelligence based, and will use different techniques like modeling, detection, inspection, or prediction techniques at the end. So regarding router, well, my name is Alvaro Marton. I'm from Router, which is one of the partners in the project. We provide consultancy and legal services in innovation projects, mainly in innovation projects related to data exploitation. And in Cdmp, we are the main responsible on data management and regulation. So now we're going to see different legal issues that may arise, in this kind of projects, or in this kind of smart manufacturing ecosystems. First of all, I think it's good to provide very simplified view of which is the data life cycle in this kind of smart manufacturing environments or ecosystems. First of all, we have the data acquisition stage. So data is collected from very different sources. It can be collected from equipment used by manufacturers, equipment that has is connected through IoT technologies. Data can come from databases, can come from many other different sources. At the end, wearables that could be used in the in the shop floor, etc. Data produced by users of the products that are manufactured, data from the suppliers at the end. So there are multiple sources of data that at the end can be used to provide different solutions in these environments. Then we have the data storage state. The data can be stored, for example, in the cloud or on premises. In the case of the Cdmp platform, there are these two possibilities. The platform can be installed on premises of the manufacturer and also provide cloud services. Then we have the data processing stage. The raw data collected is transformed, is processed to obtain data that at the end can be used to have that database decisions, or can be used for different purposes. This other stage that is important is data transmission in a smart manufacturing ecosystem. There are many actors, such as manufacturers, equipment manufacturer, suppliers, service providers that at the end can share data for different purposes, And we have also a data application at the end, At the end, data is used is applications or algorithms can be applied to this data to make an analysis, to visualize this data, and to make decisions, automated decisions that at the end can be also translated in actions in the physical world. For example, a machine can be configured differently, so this will have effects in the software at the end, in the physical world, where this machine is working. So, as mentioned, data exploitation, data from very different sources, exploitation is one of the main elements that is characteristic of these smart manufacturing ecosystems. And of course, amongst this data, we can be processing at the end also personal data. Here is the first potential legal issue that should be dealt, so should be addressed. For example, in Cdmp, we analyze the different use cases from the project, and we identified potential legal issues or risks or potential scenarios in which personal data may be processed, in a smart manufacturing ecosystem or scenario. No, here I'm providing some examples, so you can see some of them. And first of all, I would like to remind the concept of personal data. At the end, personal data is any information that can be related to identify or identifiable person. So someone that can be already or is already identified, or can be identifiable also through the data, no, that we have. So some of the examples that were provided here, and I will explain, are the following. No, the most obvious, for example, in a smart manufacturing platform or a platform that provides different applications or applications to manage data from the factories. The first and more obvious personal data processing operations is when different workers or users of the platform provide the personal data to create a profile that enables them to manage the platform and the different applications or components that are offered there. No, less obvious is the second case, for example, where data can be inferred. No, for example, I mentioned before that data is collected from the equipment, from the machines that are being used in a smart manufacturing or in a smart factory. And at the end, workers interact with these machines. So some personal data could be inferred because maybe infer, for example, some information about how workers are performing their jobs, no, or the times at when they are working, no, in the software. So if this information can be related with an identifiable or identified person, will be considered personal data, no. Also, we may have other cases where photographs or videos or images are taken from the software to keep track on the different processings, different production processes, and also the image of the operators, of the workers, may be recorded at the end, no? Which can be considered personal data. Other example, for example, is location data. We may have, for example, vehicles for transporting materials that are connected at the end, and we can know the location of the vehicle of these vehicles, and if we know who is the driver of these vehicles, we can know also the location of this person. No? So this is considered also personal data, for example. And other clear example is the use of wearables that now is starting to be used more in factories. So the operators wear these wearables that are also connected and help them to develop their work. No, so at the end, these wearables can transmit information about their performance on their work, or even information regarding I don't know if they are tired, if they, or even can infer if they are sick, or other data that could be sensitive at the end. No? So considering that personal data may be processed in a smart manufacturing ecosystem, at the end, in these cases, would need to be comply the GDPR. No, as you know, the GDPR is the General Data Protection Regulation, is the European regulation on data protection. And there are some things that at the end different actors that are operating in a smart manufacturing ecosystem need to consider and implement. No, for example, all the different data processing operations should be identified. The data that is processing this operation should be categorized to identify also if some personal data will be processed in these operations. No, and if this is the case, it's important also to identify who are the data controllers and processors in these processing operations. The controllers will be the main responsible on compliance with GDPR, and the processors has also responsibilities, but at the end they act on behalf of the controllers, so the responsibilities are different. No, and in a smart factory ecosystem could be complicated to identify who is the controller, who is the processor. At the end, we have manufacturers using data. We have application providers, software providers. We have suppliers. We have different actors along the supply chain that may participate in data processing operations. No? Of course, we need to implement the privacy by design principle in all the data processing operations, in all the technologies that will be used to process data. So at the end, this principle means that or requires that privacy is considered from the beginning, from the design in the creation of these different procedures or technologies, applications should be created to comply with the GDPR from the beginning. No, for example, if we have an application that will use data from the factory systems at the end, and some personal data may be involved, that the application could have anonymation functionalities, encryption, etc. No? Also, we need to implement the privacy by default principle, which involves that only personal data that is strictly necessary is processed. So should be assessed if it's really necessary to process personal data in an operation, and if it is, at the end, it should be done in the way that minimize the impact for the data subjects, reduce the most data, personal data that is processed at the end. Of course, we need to implement security measures to protect all the information, especially personal data. So this involves different security technical measures, access control, also recovery plans, no, etc. And all of this, all the measures that are taken and implemented should be the control should be able to demonstrate that they are implementing these measures. No, so different improvements should be kept and provided if required. No, at the end. So this next potential legal issues that may arise are related with data sharing. As you know, and as mentioned before, in a smart manufacturing ecosystem, is generated a great volume of data from very different sources that at the end is shared, or may be shared from different actors in the value chain. Can be shared, for example, between the manufacturer using a machine and the machine manufacturer or machine provider, the data generated by this machine can be shared with suppliers. Data produced by users can be shared with manufacturer, etc. No, we have many scenarios where data sharing can be or at the end needs to be shared or exchanged in an ecosystem like this. No, so there may arise different legal issues. For example, regarding the data ownership, to establish who is the owner of the data sets that are shared. For example, maybe consider that the owner is the owner of the machine that produces this data, but at the end, this data is used by the manufacturer that is the user of this machine. So there may be conflicts on the ownership of data sets that at the end is not clear, covered by regulations. No, and now it starts to be, but still there are some gaps. Also, there may be problems on protecting data sets at the end, as they're not a tangible asset. Also, it's difficult to protect them through IP protection. No, some databases can be protected, but maybe complicated also. There's another problem that is the confidentiality. Data sets that at the end are shared may contain confidential information on processes, products, etc., on the regarding the data owner. And finally, also the owner of a data set or the holder of a data set may not want that the data set is used in some ways by the entity with which is sharing this data set. No, so one possibility to try to address these issues, and I would say that is the more standard, is using data sharing agreements. No, that at the end regulate this data sharing between different actors, different parties, and can regulate different aspects. No, such as, for example, the type of data at the end that will be shared. Could be established a minimum quality requirements. Could you explain which other rights from third parties are related with this data? Also can be established clearly who is the ownership of the data sets and who's the users. Can be regulated other aspects on how will be accessed to this data or distribute these data sets, if they can be reused. Can also be established the scope and restrictions on the use of these data sets. For example, for which purposes can be used, in which territory, for how long, if the data can be enriched, can be modified, etc. No? Of course, can be agreed also the security measures that should be taken by the user of the data, no, at the end. And as mentioned before, some confidential information could be contained in the data sets that are shared. So these data sets can be protected as trade secrets, but the directive requires some actions, no, to make this possible. These requirements are contractual requirements and also technical requirements. So in the contractual requirements should be included a clause, no, specifying which information should be confidential, and regarding the security or the technical requirements are taking adequate security measures to protect the data, no? And of course, as in any contract, termination causes, establishing when in which scenarios the agreement will terminate, will be finished, and liability of the parties, no? Now we are going to see new regulations that are coming here in Europe. As you know, as you may know, the European Commission started a strategy for data in the European Union, which aims to create a data-driven society and create a free market of data where different industries, different sectors can operate, and exchange data. Of course, always complying with all the security requirements and creating a trustfulness framework. Related with this, the European Commission has released two new regulations. That is the Data Governance Act that is already in force, and the Data Act that will be enforced. We have a draft now, but will be enforced by 2023. We're going to see now these regulations, the main points, and there is another element that I think will be explained in more detail in the next presentations. That is the creation of the European data spaces, which are spaces with a specific architecture and standards, and where some principles apply to create, as I said, a space where different entities can share data in a secure way, in an environment of trust, and keeping their sovereignty or the data sovereignty. So, regarding the regulations that are very related with data governance, data use at the end, we have the Data Act that, as I said, we have now the draft that will be enforced very soon. And the main purpose of this act is to foster, to promote the data sharing, the industrial data sharing, and to create innovative services, new innovative services around data. So at the end, this act establishes measures that allow users of connected device to access the data generated by the use of this connected device, and also to share this data with third parties that may provide innovative service by using this data. So, for example, to see an example in a smart manufacturing environment, a factory that is using a machine and is generated data with the use of this machine may have access to this data that will be held by the machine manufacturer at the end. So the machine manufacturer needs to take appropriate measures to give access to the factory user to this data timely access at the end. And also, if the factory, the user of the machine, asks to the manufacturer of the machine to give access to the data to a third party that is offering, for example, a maintenance service, the data holder, the machine manufacturer, should give also access to this third party, that is offering this service. Other important point is that the regulation aims to prevent abuse of contractual imbalances in data sharing contract. This regulation aims to protect SMEs mainly, that at the end may deal with data holders that are in a better position for negotiating the data sharing clauses. And this regulation at the end prohibits or eliminates the effects of contractual terms that are considered abusive. Finally, this Act also established some rules that allow customers of different cloud-based data processing services to switch to another service of the same category. So the cloud-based data sharing, data processing services, such as maybe a smart manufacturing platform, for example, need to take appropriate measures to enable this change, and also support this change and make it possible to port the data or digital assets from one to the other service. The second regulation that is important also is the Data Governance Act. This one is already in force. And this regulation is important because mainly regulates data spaces, and it's important also for data sharing market. The main points that this Act regulates is, first of all, the reuse of data that is held by the public sector. This includes data that may have rights or from third parties, for example, personal data or data that is protected by IP, and establish a series of requirements for the using of this data by any entity, and the conditions in which this data should be offered by the public sector. That at the end should be in equal conditions for everybody, with some exceptions, and the public sector also need to make the appropriate processings with this data before offering it to other parties. For example, in the case of data held by the public sector that contain personal data, should be anonymized before. The second point, maybe is the most interesting for us now, is the establishment of the requirements for the entities that provide intermediary data sharing services, as could be data spaces at the end that provide services to enable different parties to share data between them. So there are some requirements. This kind of intermediary entities should be registered. They only can provide intermediary services, so they cannot use the data exchange for their own purposes. They need to separate the intermediary services from any other services that they are providing. And also they need to comply with some requirements not to to make the data exchange secure, no, at the end, and trustful. Finally, the Governance Act also regulate the entities that collect and process data transfer for altruistic purposes. Thank you very much. This is all from my side.
The data sharing agreement. So did you create a template in the project for the data sharing agreements?
No, we have a deliverable where we include several recommendations on the aspects that should be regulated at the end in these agreements. No, so at the end, this is kind of flexible, no? Depending on the needs of the parties, would include some clauses or different clauses. So at the end, what we did is analyze all the different sections that could be included in the agreement and provide recommendations regarding this.
Okay, no, that's interesting. That's good. I mean, often that's a thing that people they don't know what to include in a data sharing agreement. So having some input on that's really valuable. And I think you mentioned also the Data Act that's going to that looks at imbalances in data sharing contracts. So maybe part of that there'll be more work in this area.
Yes, of course. I think once enforced, we will need to see at the end what they consider abusive or not. So by now we just have the intentions not in the regulation, but we need to see how it works finally.
Thank you.
Okay, so if there are no other questions, I think we can go with the next presentation.
There's one more question from Roberto.
Oh yes. Yeah, the question: if you use a specific cloud provider services for your platform, are you enforced to facilitate the move of your solution to the platforms? At the end, I would say yes, because at the end, this cloud services is following your instructions. They are acting on your behalf. So at the end, I think the service provider, the cloud-based service provider, need to ensure that this happens. No, but as I said now, even this regulation is not enforced yet. So we need to see how it applies. No. In the reality, once it's enforced, so we will see real cases in the next months probably. Here we have data governance considers Title 2, Title 21 CFR Part 11 FDA for medical devices. I don't understand this one. I'm not sure if it's a question or a comment. This one I cannot answer it. I don't really understand what do you mean with this one. I don't know.
Yeah, maybe for medical domains or that there are strict regulation that need to be followed. So I think those requirements are very strict in the medical domain.
Okay. But this one I'm not sure. I cannot answer this one. I'm sorry.
So maybe I can just start in presentation mode. Can you see it?
Yes.
Okay, perfect. So yeah, thanks everyone for joining. So my name is Phu Nguyen from Sintef, and This is the second presentation of the day, and I think we can follow up on a few interesting points that Alvaro already shared around the. I think the data sharing is also important, and more important. But then, if we're going to share the data, then there are many requirements, there are many restrictions that we need to take care of, like about about the data, the quality of the data being shared, or the security requirements around that as well. So in this presentation, I will give you a few points, a few highlights from one systematic review that we did for around the solution for data quality in the domain of cyber physical system or Industry 4.0 in general. And there is a work that we did in the context of InterQ and Data 4.0, and with the partners from Syntep, from DNV in Norway, Illocom in Greece, and also PTW from Germany. So I think we can give a quick overview of the two projects that our work is within those two. The InterQ project is also in the ZDM cluster that you so many sister project, I think, partners joining the meeting today. So I think I don't have to go into details here. Those are a few main points for InterQ, and just to highlight that the important part for the quality is very important in terms of the process quality, the product quality, and the data quality is all of them are very key aspect that we are addressing in InterQ. That is yeah, very big, very nice project that coordinated by IDECO from Spain, and also we have many partners from different countries that you can see here. That's the second project that I also representing today is Data 4.0, and it is also targeting the zero defect manufacturing, and with them quite a strong focus on data quality management or quality management in general. And there are many partners that are also working on that. This project, like you can see, 20 partners, and it's coordinated by Syntep Manufacturing from Norway. And there are 5 pilots that you can see here, like Bentley, Bosch, Densely, Sirona, Enki, and Versa, and many technical providers as well that you can see here. So this is the two projects that we are representing, and this work is focusing on the data quality aspect of basically the more in general in cyber physical system, but it is of course many part of it very important for the manufacturing domain. So I'm going to present very maybe some highlights of our systematic review, and then we can have some conclusion based on that, and what are the next step that the two projects that I'm mentioning, we are addressing the challenges. We know data is important, but we should not compare it with the ORI, because data should be much more valuable and much greener. That's we should use to create the value based on that. And if you look the data, how we can make the best out of data is that, okay, its quality must be high, because nowadays many decision making are based on data. So we collect all the data from the manufacturing processes. We process even the high frequency data coming, maybe at the local machine, maybe in the edge layer. And then nowadays there are many approaches using the cloud-based solution with the digital twins, with the on the historical data analysis, and even online real-time data analysis possible. It is very important to know what could be about the data quality. Yeah, but we need to take into account the data quality, because it is very important with all the decision making. It is very important that we have we need to learn from the existing approaches on how to addressing the data quality and the management of data quality here in this context. So you see, like, it is more and more of data being transferred all the way from the shop floors to the edge layers and to the cloud layers, and that is a lot of things can go wrong with the quality. So we have to understand that problem. And for that, we with the other partners, we have done a systematic reviews that you can see here, when we derive our research based on the predefined question, where we derive the rest of the of the review protocol that you can see here, with very systematic way to search and to select the primary study. We extract the data based on the taxonomy, and then we synthesize the data, and then we analyze them very in a very systematic way. So it is very well known methods for analyze the landscape of current approaches in one specific area. So then we know what is missing, what are the existing solution, and what are the missing points that we need to contribute in terms of the research projects that we are working on now. So just to quickly go through the research question. For example, in the research question 1, we want to understand how are the data quality issues handled in those primary study that we call them on the one that we found and selected. So there are many things that we can analyze on that, like what types of data that we use, and the practices to handling the data quality, the requirements for quality, and the rules and the metrics exist, the methodologies for monitoring. So I think we not have time for everything to present today, but basically we look into the data quality issue, we look into the software technologies, because that is that is more and more important when we talk about edge computing, cloud computing, also involved in the manufacturing process nowadays. And the database technologies, yeah, used in different layers of the IoT or cyber physical system domains. So of course, machine learning or AI's techniques are also important to help with the detecting the data qualities, even fixing them. So we can also give some highlights on that today. Like I said, we derive our search process and selection process based on the research question, and we use a search string and we apply it to the on the most popular application databases, like you can see here. And then we also conduct some manual search to find the primary study that we want to extract the data. So here you can see the inclusion criteria that we have here, so that it must address the data quality and in the domain of IoT, industrial IoT, cybersecurity system. And of course, we want to learn about the software engineering, the machine learning, the statistic, the engineering approaches for data processing. So those are important, and we, of course, we control the quality of the study that we selected, and it must be a peer review. It must be kind of a published paper. It's not yeah, some random papers that we select. So we have very strict control on that. And then we analyze them based on the predefined taxonomy that you can see here in the different aspect of from the point of view of data types, the processing, the quality, and the software engineering aspects, even the IoT architecture as well. And then when we apply, although a very systematic way to search for the publication and to look into the approaches, we have the strict process to scheming and scanning and to selecting all the important study that we think that is contributing to answer the research question that we define. And then we found finally we found only 51 publication that they have some explicitly addressing those aspects that we want to understand. So then we analyze them based on those study. I don't go into details of the study, but okay, let's see what are the highlights that we can answer those questions around data quality issues. So based on those publications, we see there are many application sector that in the domain of industrial IoT in general. But then if we look into the closer into the specific sector, we see that it is quite important to highlight that manufacturing domain is the biggest one in all the publication that we analyze. So it means the data quality is really important, very more and more important for this domain. And then you see a bit more details in this domain. What are the smaller sector? But basically, if you look into here, there are if we divide it a bit in a bit overlapping as well here, and so it's not perfectly separated, but basically we can highlight that manufacturing is one of the biggest domains that care about data quality. And then when we look into the data types that we analyze in the study, with the time series data is a big part of it. There are also many things about the semantics of data, the images data, but the time series is and even some data that is used in the simulation only is not real data, but there are some part of it is simulated. And then in manufacturing domain, you can see the time series data are a big part of the data that presented in those papers when they addressing the data quality. But there are different semantics data that or the mixed sets of data. So it is a bit of the overview of what kinds of data that we look into. And then the data quality issue that mentioned in those papers are the outliners that you see. It is I think there are quite many things that can go wrong with the data. If we don't take care of them, then many things could go wrong from the semantic perspective, or from the so it many cases that it also kind of the very domain specific semantics that we need to be aware of when those data quality issue is not conform to what is needed in those domain. So here there are some part of it also related to the bad quality data by the incident where malicious data even can be inserted into the main data set. So yeah, that is some issues that you can see. But then the requirements that also mentioned in those studies that we can find is that it, of course, the data must be fit for the purpose. But then in the manufacturing industry, I think there are many requirements that, for example, the dimension should not be missed, or the data being influenced by the harsh environment in the workshop. We also that need to also be documented into the requirements, because or duplicate data caused by high sampling frequency. So those are quite a bit quite specific for the manufacturing domain. And the requirements should really taken care of very in some cases the specific requirements for the domain as well. So but in terms of the general of the consistency of the data stream, I think there are quite some general rules or requirements that you can see from here, like the completeness, the consistency, the conformity, and accuracy, and so on. So those are the we can see about the requirements in terms of the generic requirements, and also the bit of the domain specific requirements that if we narrow down into each domain. The rules and the metrics exist. So I think we also found some set of metrics that the authors of those primary studies they propose to in terms of what metric that can be gathered to measure the quality of data. So here you can see some important metric like in terms of frequency, in terms of the validity and completeness. That yeah we so, and even the data also must be valid in terms of the format as well in some cases. So here we have some overview of what are the important metrics that can be used. And then once we know the metric, there are some methodologies that use to monitor and visualize the data quality as used. So here we see that there are different statistical monitoring of data to discover the quality issues. So here, if you look into the means, the standard deviation, there are different data analysis that can be applied to single out those quality issues. And then data dependencies, yeah, it is also important to be measured as well. Yeah, I will just skim through some highlights, so then we can, if there are any questions, we can go into the details. But then in terms of the software technologies, maybe we take a few highlights that we can mention about what kind of technology that we should be aware of when we talk about data quality for industrial IoT system or for manufacturing as well. So if you look into the IoT in a reference architecture, there are layers. Basically, there are 7 layers, or we can also look into the 3 main layers from the local processing or in the local machine soft floor. But then it go to the edge computing layer, and then to the cloud layers. So if you look into those layers, there are there are quite many studies that they only mention about the data processing techniques, but actually the details of the architecture, where the data process and the quality being checked, it is not clear in those studies. So it means that those studies, even though we know that edge computing is getting more important, cloud is a big part of it. But I think they mainly focusing on the data processing technique, but not necessarily very clear about the architecture and where data being analyzed and how it could impact the quality. So here we also see some trend that the edge cloud orchestration for the data processing is also starting to be more important, and because of the involvement of some digital twins approach in manufacturing, then those edge and cloud orchestration is more and more important. And then the edge computing part is also very promising, because we see that edge computing can play a big role, and especially with the European for European countries, there is the new kind of technology areas that can take that European country can take the advantage and try to compete with the rest in the world in term, because cloud computing is basically quite well established, but edge computing is still a huge potential that can be done here. So basically, there are many things we can do now at the edge layer as well. So yeah, maybe I can also give a few highlights about the databases technology. So blockchain sometimes is mentioned to ensure the security data sharing, big data system, and then yeah, the traditional kind of relation database management system is still there, but there are more time series database being used, and even sometimes the graph oriented kind of database as well. Programming languages are important, but then okay, we will not go into details, but actually, of course, it is quite pretty much diverse in terms of the programming languages and also the tools that are being used. But we see that a lot of tools for machine learning and AI supported application that being also mentioned in those primary studies. The last question that we maybe have a quick answer for is those in terms of the machine learning and AI's modules. So I think here there are many approaches that already try to repair the data, fix anomalies, detect anomalies, fix them, and even maybe not in this presentation, but we not have time for that. But there are some part for even for kind of on the fly data. Time series data, that what are the requirements that can be important for time series data to enable on-the-fly prediction. So more on that we can share with you later if you want to have more details, because we submitted a paper, a journal paper on this to ICM computing surveys. But okay, the aim for the data repair techniques that you can see here is can repair many things from us, the semantics, the timestamp, missing values. So I think we from Syntec, for example, we also are working on some approaches for erroneous data repairs in the InterQ project, and in Data for Zero even we also have some approaches for event detection, so that it can also support for process mining. And in those primary study that we analyze, we see that of course there are different approaches, but I think there are still not yet any very kind of many very all-round or complete kind of approaches, but it is a few approaches that they start to propose how to maybe complete the missing values, how to do a bit of some ad hoc or specific way to fix data. But I think we haven't seen yet any very more systematic way of doing that. Reinforcement learning methods also mentioned in some study as well. Event-based IoT application that it also some approach for data repair for that as well. But so we maybe we don't have time for all the specific results, but I think we can just to wrap up, that those algorithm and approaches that mentioned here, they are a bit specific for of course for their problems, but we haven't seen a systematic way to control the data quality in general. And that is exactly what some part of it we are addressing in the queue, and some part of it we are also working in Data 4.0. So I just want to give some conclusion that we that we can give maybe that the highlights that we show so far, it is just to raise the many gaps that we should address in terms of how to look into the data qualities and how to address the management of the quality at different layers. The data quality issues that you can see that there are many kind of issue, but outliners or missing the values or data veracity are the three main ones that we can highlight. And not many studies that discuss the source of data qualities, and that is very important, especially in the manufacturing domain, because then we know how to fix them, and we know what is going wrong with the manufacturing process. The current data quality management techniques, I think they don't consider the different engineering layers from the IoT perspective, for example, and that I think it is also very important to be part of the solution. The programming language is it is very specific for the solution domain, and yeah, I think in the context of the InterQ and Data 4.0, I think we are working more on the quality part, and it is like I mentioned for the product, process, and data qualities. There's one point very important that Alvaro mentioned in previous presentation about the data sharing, and there is one of the big part of InterQ is to enable the data sharing between different stakeholders, because once we can documents, we can make the trustable data being shared using these approaches like the quality hallmarks and the structured framework that being developed by InterQ, that I think we also presented together with Mauro from engineering about the framework. I think that is very important solution. And in the queue also, DNV and Syntec, we have been working on the guidelines for security and data management governance. So we do not have time for the details here, but if anyone interested, we can please send us an email for me and Karjon. I think he will present more on the data management soon. And then the last point that I mentioned about Data 4.0 is that I think Data 4.0 is very interesting, that also have the data management, the DQM platform, data quality management platform. That in the cloud base, but there is also a part of the edge computing part is very important, because in here we can also do many experiments to see how data quality can be managed at the edge layer to pre-process into before it's sending to the cloud. And the NERV platform is one good example, but provided by TT Tech in the project, that we also trying to do more experiment on. And I think that is very promising. So yeah, those are some highlights of what we want to present in the context of Data 4.0 and InterQ. So thank you for your attention.
Thank you very much. I don't know if there are any questions.
So yeah. So I don't know if I a bit taking too long to present, but yeah, I hope it's give an overview of the highlights that we have, and how we are working on the different solution in InterQ and Data 4.0 to address the gaps, and also to advance the solution, the technologies.
So thank you very much. And if there are no other questions, I think we can go with the next presentation.
Okay, Alvaro, will you share the slides? You're muted.
Yeah, Alvaro, can you share the slide from Kajon so then he can?
Oh, yeah, sorry. I'm open. Can you see the presentation?
Yeah, that's good.
Yes.
Okay, so I go to the next one.
Excellent, thank you. How are we doing for time? How long shall I use?
I think 15, 20 minutes.
Yeah, okay, I'll stick to that then. Excellent. Okay, so thank you, Fu. This is Fu mentioned in his presentation that we've been working together on the InterQ project. So I won't give an introduction to the project, but I'll be talking a bit about the delivery we did around security, data management, and governance. However, I'll be concentrating on the data management and governance side of things. Because Sintef and Fu, they had the responsibility for the security side of things. So just a quick pointer to what we were looking at. We were tasked to provide guidelines for security, data quality, management, and governance in issues to the project. And as part of that, we're to assess the current practices in Industry 4.0 and the gap between this and the state of the art across industries. So lots of words there, but basically helping the project in terms of data. The focus I'm going to talk about is the data quality. So they have the manufacturing machines, there's lots of data, there's lots of sensors, and that data is used to make decisions. So how do you ensure that there's good quality data, and that we know that we are making decisions based on good quality data? And to do that, there's data management and governance to help that. So we're talking more here on the soft skills rather than the technology, and how does your organization need to be set up to actually have a focus on data quality. It's not always necessary enough just to buy some technology. You also have to have the organization to be behind that, to understand that data quality is a problem, and have a structured approach to across the whole data value chain in an organization. Okay, if we just hop on to the next one. Just a quick, a brief introduction. I'm from DNV, which is a Norwegian-based company, and we work in the area around assurance and risk management. So our tradition is we've been assuring things over many years, and we started off assuring ships. So checking the ships are fit to sail, can they traverse around the globe along the oceans in a safe way. So that's our background, and now we do assurance across lots of different things: energy, medical, oil and gas, and so on. So lots of different areas. And in a way here we are talking, well, now we're moving more to digital assurance. So where rather than previously going out to traveling out to a ship and checking and banging on the hull to check that there's no rust and so on, we're moving more to digital assurance, where we are using sensors and data from those sensors to do that assurance remotely. So not spending time traveling around the world doing this, that in situation work, but more digitally. And then obviously we have to trust the data that's coming from those sensors. And exactly the same with the InterQ project, they have to trust the data coming from the sensors on their machines. Okay, would you hop onto the next one? Just as the background, these are some figures and basically around data quality, and the point is that having poor data quality is costly. This is not specific for manufacturing, this is across lots of industries, but having good quality data is important, because we increasingly use this data to make decisions, and if the data is poor quality, we can only expect poor decisions. Okay, next. So the whole point of this is that we want to ensure that our data are fit for use. So we have our data on the left-hand side of this picture, coming from IoT, coming from physical assets, sensor-based data stored in the cloud, and we have to trust the data coming from those. So how do we do that? We want the good data quality. And the way to ensure that is to have data governance and data management, and that means we can then trust the quality of our data, and then we can use that to create business results, to do analysis, and use that for decision making. So that's the process, having good data governance and management in place. Okay, so what did we do in InterQ? If we just hop onto the next slide. One of the, we're not finished this this delivery yet. It's going through across the whole 3 years of the project. But in the first year, the first period, we created a guideline for security and data management and governance. So we went through and looked at what do we need? How can we help the InterQ partners in this area? So we spent a lot of time going through and interviewing and so on. If we just hop onto the next slide of that, we had a defined process where we analysed the state of the art and practice. So we looked at research publications. Fuse talks about that. One example just there in the paper we wrote. We look at international standards around this. We look at white papers, and also look at current practices within the InterQ partners. If you just go on the next one now, and one more. Okay, so what activities we did? We gathered information on the state of the art, and that was based on existing knowledge within our two organizations. So Syntef on security, us on the data management. And we also sent out a questionnaire to InterQ partners to find out what are their current practices at the moment. So what is the baseline? What is the as-is level within those organizations? And that provided us some good input with follow-up interviews to get a good insight. Okay, so that was provided the base for our work, and then based on that, we then created that delivery report, which we saw on the first one. Okay, just want to delve in a bit of the detail in the next slide, Oliver. And so we created the data governance and management guidelines, and we see that that flow again slightly different on the top here, where data governance sets the framework for being able to carry out data management, and then that ensures that we have good data quality and we can trust that data, and that means we have trusted decisions. And then in the InterQ project, then that should contribute towards quality products. And when we created these guidelines, we didn't start from scratch. We based it on an existing recommended practice, which we at DNV have created, a data quality framework. And we also based it on an international standard, ISO 8000. So building on existing work that is already used in industries, not necessarily in the manufacturing industry, but it's used in lots of different domains, and then applying that to the manufacturing domain. So learning from others. And this then provides a dependable, tested foundation for managing data. And the guidelines are aimed at those in the organization are responsible for data. And we also looked into data sharing, because obviously we want to share data between the partners in the consortium, and how they manage the data, and how you can help with secondary use of data. So if you look at this bottom of the slide, there were 8 different areas that we provided into these guidelines. And these are typical areas which are important, that have to be in place to ensure good data management. And at the start, Alvaro showed the Dharma wheel, which is a more comprehensive framework to do exactly this. And you'll find these areas maybe called different things in that Dharma framework as well. But this framework is more we feel is more practical relevant for this project. So governance, having the people, having the organization behind the fact that we have to do some data management. Organization people, so we have people that have a responsibility for data quality and data management. We have data quality processes. And in terms of process efficiency, do we have good, do those processes pick up all the data quality issues? And if a data quality issue is found, a process is in place in the organization for them, for the employees to then work out, to do a root cause analysis and find out what the problem was. So not just get some Excel data and correct it in the Excel sheet and go on and run the analysis, but actually go back to the source and see, well, why do we have a data quality issue? Requirement definitions, that's where we define requirements to data quality. So what do I define as good data quality, and how do I check to see that that requirement is being met? And it could be as simple as that our data, the temperature data, is between minimum 0 and 100, and if it's outside that area, then it's poor data quality. We then have to measure that, maybe create a dashboard to show the data quality. And then to do this, you obviously need architecture tools and technologies, which Fu alluded to earlier on, and also following data standards as well. I mentioned the ISO 8000 data standards, but what industry standards have to be are relevant for managing and having good data? Okay, hop on to the next slide. As part of this project, what we also did is one of the important things is getting the partners on board and getting an ownership to data management and understanding how it could help in their processes, in their manufacturing lines. So we ran a training course, how to get value from your data, for the IntiQ partners. So I just wanted to share 3 or 4 slides from that, because it provides a background of what we're trying to do. Okay, if we just hop into the next one. Okay, so in terms of bad quality data or poor quality data, there's lots of different things that you have to look at, and it's very difficult to know where to start. So putting the pieces together, and that's what we've done in that framework, and in the same way on that little picture of the car, that you need some instructions where to start. You don't maybe start on the hardest thing, you introduce it gradually in an organization. On the next slide, why do we need data management? This comes from Dharma, which Alvaro mentioned earlier on, that the primary driver for data management is to get good value from the data assets, just in the same way that you get good, that you have good management of financial and physical assets, and that enables organizations to get value from those assets. So I think that's a useful thing to have in the back of mind. Why are we actually doing this? We're not just doing data management for the just to do it. We do it because we want to manage the data in a good way so that we have good data quality. Okay, I'll hop on to the next slide. I mentioned ISO 8000. This is a good view, or this is how they view data quality, that you have 3 types of data quality: syntactic, semantic, and pragmatic. And they're always useful to have in the back of mind when you're talking with domain experts and helping them to define requirements of data quality. Setting them up in these 3 categories is quite a good way to do that. I don't want to go into the detail of this, but we'll be sharing the slides afterwards. And if not, get in touch and I can share as well. Okay, if you just hop over the next slide and then go to the number 14, hop over that one. Yeah. One of the big issues in organizations is the culture. Well, it's not an issue, but it's a thing that we have to be aware of. We have to build a data quality culture in organization. A lot of our colleagues have lots of different they're working on projects, they've got timelines, they've got a budget, so they all in the darker colors in this picture, and they are pulling one way, and they don't necessarily have the time to spend time in data management and ensuring they have good data quality, even though they do actually depend on good quality data in their projects. And the person on the left, the white and knight, the knight in white armor, is the data management person who's saying, no, we actually have to spend some time looking at data management to ensure we have good data quality. So we always have to be aware that introducing a data quality culture in an organization is difficult, but there's a value at the end of the day. Okay, if we just hop on to the next slide. Okay, one final thing, just one more. One way to help introducing data management in an organization is, in addition to the guidelines, which is obviously there's a lot of reading to go through there, we thought it might be valuable to just have a quick checklist that partners can run through and say, okay, what do we need to ensure that we have good data management? So it's a very simple checklist in those 8 areas which I talked about earlier on. So 5 or 6 questions for each area, so for governance, organization, and people, and just a simple checklist for a partner to go through and say, okay, do we have these things in place? And if we don't, it provides a guide to where I could start in my organization. If we just hop onto the next one there. And this checklist provides a simple overview in these different areas, how mature we are we in these different areas, and maybe which one should we have a look at. Should I concentrate on the organization, or should I concentrate on tools and technologies, and so on. Okay, our next slide is the last one. So in summary, we were applying data management governance to Industry 4.0 based on other domains and learning from them. And we provided a framework for adopting data management in Industry 4.0. And one final point is the culture is really important. It's we can provide as many guidelines as we want, or write as many guidelines as we want, or buy as many software systems as we want. But if an organization is going through a digital transformation, it has to implement these guidelines and so on. The culture is the alpha and omega. If the culture is not in place there, nothing will happen. So it's all about culture and change management. Okay, thank you. It was a bit of a rush, but we wanted to get a bit more track on the time.
Thank you very much. I don't know if you have any questions.
Okay, and if not, feel free to get in touch afterwards, myself or through. Yeah.
Okay, so we go to the next presentation.
Okay, tell me if you can see my screen.
Not yet.
I believe now you can.
Yeah. Okay, thank you.
Okay, nice. So, hello, I'm Vagelos Bektis, and I will present you the I4q solutions that support data governance and implementation. Sorry. So, what does the presentation include? At first, we're going to see what is I4q, how is data governance connected in manufacturing, some standardization and data space layers that are used in the I4q project, and 2 of the solutions. The one is I4q DIT, Data Integration Transformation Services, and the last one is a message broker solution. Moving on, the consortium is made up of 24 partners, and some of them are industrial, like Wearables or Factor, which are from different sectors, like white goods, woodworking, and metal machining. There are implementers, like TIAG, SESI, or AIMPLUS, which work on industrial communication protocols, machine tools, etc. There are technology providers like IBM and TNG, which work with software and IT. There are also research and development like CERT and Igerland or TUB. And finally, there are specialist companies like FBA or DIN, which work with dissemination and standardization. Moving on. Okay. The challenge that the I4q tries to solve is that in order to meet the customer demand for customized products at the lowest possible cost, without sacrificing quality or efficiency, manufacturers must constantly innovate and improve their processes. Therefore, it is essential to cut down on production cost and lead times, as well as waste, scraps, and defects in order to boost productivity. The implementation of zero-defect strategies also plays a decisive role. And there are also several product quality optimization methodologies and tools that have been developed, such as extensive use of sensors, zero-defect approaches, and automated smart processes. The I4q project's end goal is to facilitate online monitoring and control of manufacturing processes by delivering a comprehensive suite of solutions based on sustainable IoT capable of handling the massive amounts of industrial data generated by low-cost, smart, and compactly sized interconnected factory devices. Sorry, there's a problem with my PC. Okay. It includes 22 solutions. 17 of them are software tools and 5 of them are guidelines. The I4q Reliable Industrial Data Services is an Internet of Things toolset for ensuring data quality, traceability, and proper use with the end goal of enabling continuous process qualification, quality diagnosis, configuration, and certification throughout the manufacturing lines. Now, the I4q framework is at the same time holistic and modular. It can be described from several angles: business, functional, or implementation, and it's grounded in a reference architecture. Includes the supply chain, all of the tools and all of the processes used in the production, as well as the necessary digital models and ontologies. And as far as the capabilities, microservices are the backbone of the I4q framework customer architecture. Functions are organized into 5 core capabilities based on the data cycle, ensuring data integrity. Those are sensing, communicating, computing infrastructure, storage, and analysis optimization. As far now as data governance and manufacturing goes, what's data governance? Data governance is the basis upon which manufacturers assure the effective use of essential data by providing users with the capacity to handle, manage, and secure them. Some of the benefits that this includes is accelerating time to market, enhancing efficiency and boosting operational performance, in which I4q project focuses on, enhancing the customer experience, and identifying supply chain-wide possibilities. What's ensured by the data governance is that the teams can identify and evaluate relevant data, and all individuals access and utilize data appropriately. And finally, effective and efficient data management. Moving on, there are some methods and some challenges in data governance. The methods include centralizing, optimizing, and unifying the data, improving the one-to-one customer experience, accelerating onboarding of new workers, managing and mitigating risk, enriching the quality of data, which once again is one of the main focuses of I4q project, centralizing data storage systems. As far as challenges goes, there are ineffective monitoring system, insufficient workflows, and difficulties optimizing the global supply chain. Now, as far as the standardization goes for the project, 2 of the 6 most important identified standardization potentials for the project target, firstly, the manufacturing line data certification procedure, and secondly, trying to ensure data privacy and security. As far as the manufacturing line data certification procedure goes, there is a first version of the I4q manufacturing line certification procedure that was developed for the deliverable 5.6. And there's also a guideline that includes an audit procedure and an IT assistant tool. This includes and aims to ensure high data quality in manufacturing processes, includes recommendations for processes reconfiguration and audit strategies. The basics of an audit standard like ISO, here we can see, are covered in including vocabulary, principles, and roles. There are prerequisites that are defined and data quality standards that are used to develop audit criteria. And also the digital tool is presented in its initial version as a questionnaire. There's also a second version that will be developed for deliverable 5.12 and will be released in November. There's also a plan to initiate a standardization document with the procedure. Moving on. In order to ensure data privacy security, there was a meeting with an expert for cyber security. He confirmed that IEC, that the standard series is appropriate. So in the deliverable 3.5, the cybersecurity guidelines describes, among others, the different relevant standards that exist. The first one lays a roadmap for enterprises to follow in order to attain the best-in-class performance through process improvements. I4q also proposed the usage of cryptography. I4q does not aim to meter the maturity of the compliance level that the standard proposes. And finally, responsibility to each company to follow or not the standard is to themselves. We also have to clarify which partners need to implement this standard. Moving on to the Data Spaces Association. Data exchange and data linkage in a trustworthy business ecosystem can be made much easier with the help of the International Data Spaces, which is a virtual space that makes use of proven technology and governance models from the data economy. IDSA's purpose is to build a digital feature in Europe and beyond, in which all participants have equal access to secure and sovereign data exchange across trustworthy partners, allowing them to fully capitalize on the value of their data. Now, there are four main design principles, and the first one is data sovereignty. A person or an organization, data sovereignty exists when it has the power to exercise unrestricted control over their economic data goods that belong solely to that entity. Secondly, for there to be an even playing field in a data area, there should be no insuperable obstacles for new entrants. When all the factors are equal, companies compete based on the value of their data and services and not the quantity of the data they possess. Thirdly, there will be a set of agreements regarding the functional, technological, operational, and legal aspects of European data spaces. And all of those implementations of data spaces that adhere to those agreements will make up the infrastructure for European data spaces. Now, what's described as a soft infrastructure of this sort would be completely transparent to anyone using the data space. Interoperability, portability, discoverability, security, and so on are just some of the functional and non-functional requirements that will be involved. And finally, good leadership is required to plan, build, and keep the playing field level for information exchange and sharing. It is very important that all parts involved feel heard and valued, and this group incorporates not only organizations, individuals, and government agencies consume and contribute data, but also their technological partners and IT specialists. Now, regarding the data space architecture requirements, the first one is data sharing empowerment. It is about ensuring that decisions may be made by suitable parties. This means that tools and organizational practices are accessible for governance, citizen engagement support, data sovereignty support, and federation. Second one is data sharing trustworthiness. We're verifying that data sharing environments fulfill all the necessary conditions is key to establishing trust in them. Data sharing applications must be built with security, privacy, and assurance in mind from the start. Moving on, data sharing publication is the goal of facilitating data release is to make data discoverable by users. Data sharing economy is establishing a data sharing economy calls for financial incentive mechanisms, agreement mechanisms, and non-financial incentive mechanisms to facilitate data sharing and exchange. Data sharing interoperability is about the capacity for all applications in data spaces to produce, use, transfer, and successfully exchange data. Data interchangeable APIs and data models that allow for semantic, behavioral, and policy interoperability must be developed for this purpose. Now, when it comes to interoperability with to interoperability, trustworthiness, and data processing. Data space engineering flexibility means allowing engineers to add their own unique features to data processing applications and data platforms. And finally, the goal of the data space community is to increase the frequency with which data space solutions are used. Solutions that are open, reusable, and open source and long-lasting fall under this category. Moving on. Okay. Regarding the reference architecture of the project and the data space tier, as a result of requests for more control over who can access the data, how long they can keep it, who can use it, who pays for it, and how much it costs, the I4q reference architecture was revised in order to include the data space tier. Now, using the IDS connector, data space tier broadens and improves the compatibility with forthcoming manufacturing data spaces. Interoperability amongst I4q reads is promoted by making data sovereignty a user requirement. Moving on, we get a closer look. Here is the layer. Okay. The industrial, business, organizational, and operational agreement are all part of what makes up the industrial agreement and coordination framework, which serves as a guide for meeting certification standards. The IDS metadata broker is an all-encompassing connection that allows for conversation with other international data space components through the provision of standard interfaces. Specifically, it may process notification from IDS connectors about changes in the system, including as new data becomes available. An IDS provider is a third party that facilitates the development, maintenance, management, and validation of identity information for IDS participants. Now, a clearing and settlement service provider for all financial and data exchange transactions conducted within the international data spaces is also known as an IDS clearinghouse. And finally, there are different types of connectors that can be identified: base connectors versus trusted connector, for example. And IDS connectors are specialized communication servers for delivering and receiving data in accordance with the generic connector specification. Moving on, we take a look at one of the solutions we developed, which is data integration and transformation services. I4q DIT is distributed server-based platform able to prepare manufacturing data for being efficiently processed by microservice applications. Some of the elements that are included are in the solution are reading, cleaning, storing, indexing, and so on of the data. The solutions offers a variety of pre-processing functions in order to transform the raw data that we receive from different pilots. A simple diagram of the DIT's architecture is seen at the bottom of the screen, and we can see that the solution firstly imports the data, which can derive from different sources like databases or online sources or other pilots. And then we clean, signal, and the data and extract some new features, if it's necessary, of course. And at the end, we will produce some new data that we provide to the other solutions providers. Moving on, we offer the 5 following features. First of all, we can read different types of data from different sources produced by the manufacturing workflows. The solution works as the data input component for other solutions that are provided by the I4q project. It is able to read data from the data repository and directly from sensors and from other various datasets that are used in the project. The data preparation that takes place is cleaning, pre-processing, extracting features, data filtering, and we also do data harmonization. And finally, we provide integrated datasets with homogeneous structure of different recordings from multiple sources in order to prepare them for further analysis for the other solutions. Now, how does DIT link with the data governance? Data integration and transformation services provide support to the project by developing functions that enhance efficiency, boost operational performance, and ensure the quality of data, thus supporting the process and technology part of the data governance procedure we saw earlier. Finally, we take a look at the message broker solution, which is not a solution per se, but a tool that helps connect all of the solutions. The main technologies being used are Kafka and Docker. We have a server up and running, which contains 2 Docker images, one for Kafka and one for Trino, which is developed by the ITI and for the data repository solution. And the main concept is that each solution creates a topic that contains the data either pre-processed or not. And there's a second solution that consumes this topic and collects the data. And that's pretty much it. Thank you for your attention. And any questions, I'll be happy to answer.
Thank you very much, Evangelos. I don't know if anyone has any questions regarding this last presentation or any other of the presentations before. Close. I have one question for Carol John.
Sure.
Yes, it's, from your experience with this project, maybe other projects, you talk about the culture and the people and how it's essential at the end that people is aware about data management and quality. So from your experience, which are the, let's say, the actions that are more effective to raise this awareness amongst people, the ones that you see that at the end had more impact from your point of view?
Yeah, that's it's not easy, and maybe I can talk generally rather than just on the IntiQ project, because we work with a lot of companies around this. And I think often we found success when we've picked up a use case or an example in a company and showing them the effect of bad quality. So maybe they've made a bad decision, a bad business decision, or whatever that may be, and then using that as an example and going back and seeing why data quality might have caused that bad decision, and using that as an example of how it's had an effect on the business. And this is having bad quality data is actually detrimental to our day-to-day business, and then using that as a base to say, okay, well, how can we improve this? And then talk about the 8 areas that we mentioned that there was a slide on, and build on that, and also not start at the top and say, okay, now we want to do data management across our whole organization. Start in the small, find some business cases that you can work with and apply data management to those, and then show that that's successful. Hopefully it's successful, and then build on that in an organization. I think they sort of main takeaways that we are picking up as we're working with customers.
Thank you very much. I don't know if there are any other questions. If not, I think we can close the session. Thank you very much, especially to the presenters, and also to all the attendants. I hope this has been interesting for you. I think we can close now the session. Thank you again.
Thank you very much.
Thank you very much. Thank you. Bye.